So in a picture, you would have these dashes for congruent. What would be in the picture to show that they're parallel? Little arrows, yeah. And the number of arrows or triangles would show you which ones are parallel to which ones. So opposite sides are congruent parallel. That's the first property. The second property dealt with opposite angles. What did we know about opposite angles? They're congruent to each other. So if this one was 80, this one would be 80. Opposite angles are congruent. What do we call the angles that are right next to each other? Consecutive. They're not congruent. What are they? Supplementary. So consecutive angles are supplementary, so this would have to be 100, and across from that would have to be 100 as well. Because how many degrees are in a four-sided shape? 360. Because 180 plus 180 makes 360, if you remember that. But consecutive angles are supplementary. Consecutive angles are supplementary. The last one deals with the diagonals. What do we know about the diagonals? They bisect each other. So this diagonal would be congruent to this diagonal, or this, and then this one would be the same length as this one. The two diagonals cut each other in half. So for any parallelogram, these are the four properties. Any parallelogram. There are three special types that you already know about. You just might not know that they're a parallelogram. And we're going to talk about them later today. To continue the review, state which theorem you can use to decide if they are a parallelogram. So we did this in 7.3. So in the first picture, which property is shown that proves that this is a parallelogram? Opposite what? Well, does it show any information about the sides? Opposite angles are congruent, that one said. So it shows the opposite angles are congruent, so that's the property that proves that this is a parallelogram. The opposite angles are congruent. Number 2, which property is shown? The diagonals bisect each other. You could also, if you want to shorten it, diagonals are bisected. But what you can't put is diagonals bisect. That's not a full sentence, and it's not because I'm being picky. You're going to learn about diagonals bisecting something else today for a rhombus. So we'll talk about it here in a second. So just make sure you don't write diagonals bisect. You have to tell me what they bisect. They bisect each other, or the diagonals are bisected in general. That would be fine. Number 3 and 4, find the value of x that makes the quadrilateral a parallelogram. So in number 3, if this is a parallelogram, what do we know about 3x plus 5? It would equal 41. They'd be the same length because they're opposite sides, and they would be congruent. So then to find x, you would subtract 5. What is 41 minus 5? 36. And so then x would be 12. Number 4, you do something similar except for, if I set 2x and 2x equal to each other, would I solve for anything? No. So even though they do equal, and they clearly do, because they're the same, you don't want to set those two equal. You would want to set these two equal. I'm just going to show you that, and then we'll move on, because we all know how to solve an algebra problem like that. When you're ready, you can move to the next page. Boom. All right, so find the indicated measure. We're not going to explain our reasoning because you won't be asked to do that on a test. You'll just find it. This is a parallelogram, and we know it because it says it. This little symbol is a parallelogram symbol, and that's how they named it. So first we're going to find the length of CD. So what is the length of CD going to be? 16. It's congruent with the side it's opposite to, which is 16. AE is part of a diagonal, so the length of AE will be 7. BCD is an angle. What's the vertex of BCD? C. So when we say BCD, we're talking about this entire angle. We are only given 140, which is this angle, and then we're given 43, which is part of an angle. So which of those is helpful to find angle C? 120, because what do we know about opposite angles? They're congruent. So BCD will be 120 also. ADC, ADC. So a lot of people think it's 43, but if you look, do you see how 120 is pointing to like that arc? That shows that that's the whole angle, but 43 is only this part of ADC. So you need to use one of the original properties. If this angle is 120 and this angle is 120, what is ADC going to be, which is this angle? 60. All right, the length of AD will be 7. The length of BD, 20.4. Yeah, it will be. So a lot of people, whenever they see this in print, they can't figure out if things are angles or sides. It doesn't have a bubble at 10.2, so that's a length, and it's the length of the nearest, segment. So it would be this one, and which means the other one is also 10.2. So add them together, and you get 20.4. ABC, which is this angle. What will the measure of that one be? 60. And then last, DBC, which is this angle. It'll be 43. Because what relationship does 43 have with DBC? Alternate interior. Perfect. Perfect. So we're going to learn about 3 shapes. We're going to talk about them and then really learn about one of them today and then the other 2 tomorrow. There are 4 special parallelograms. Not 4. There are 3 special parallelograms. I'm sorry. The first one is a rhombus, so go ahead and label a rhombus in the middle-ish of your paper. What makes it special is that it has 4 congruent sides. So a rhombus has 4 congruent sides. Next week on your properties quiz, you will need to know that definition. So 4 congruent sides. All right, and then the next one you can probably guess. What's the picture to the right? A rectangle. A rectangle is a parallelogram with 4 right angles. So it's a type of parallelogram with 4 right angles. My first hour debated with me for a minute. So it's a type of, both these are type of parallelograms. So they have the original 4 properties. So if you think about it, the opposite sides, what do we know about the opposite sides? Congruent and they're parallel. Is that true for these? Yes. What do we know about the opposite angles? They're congruent, all right? So I know it's easier to see on a rectangle. They're congruent. They're both 90, right? What about consecutive angles? What do they have to be? Supplementary. So the angles next to each other have to add up to 180. What's 90 plus 90? 180. And then I know you don't see it yet, but the diagonals bisect each other. So they have all 4 properties of a parallelogram because they're specific types of parallelograms. When you take a rhombus and a rectangle and you put them together, they make a square. So a square is both, it's a parallelogram. It has 4 congruent sides like a rhombus, so it has all the properties of a rhombus. And then it has 4 right angles, which means it has all the properties of a rectangle as well. So when we learn the properties of a rhombus and a rectangle, they apply to a square. And I'll show you. You can flip to the next page. I'm going to show you a Venn diagram to kind of explain more about the square, rectangle, rhombus relationship. So all of these are quadrilaterals, and now all of them are parallelograms for various reasons. All right, so all of them have 4 properties, the 4 properties that we talked about at the beginning. Rhombuses have all congruent sides. They have extra properties in addition to the 4. Rectangles have all right angles. They have extra properties in addition to the original 4. And a square is both a rhombus and a rectangle. So whatever properties a rhombus has, a square has. Whatever properties a rectangle has, a square also has. Because a rhombus and a rectangle are like the mom and dad, and their baby is a square. So whatever properties a rhombus and rectangle have, a square also has. You can think of it like a dog. Pick a dog that's a mixed breed. A labradoodle. I don't know how to spell that, but we're just going to pretend that... I know it's one word, but I don't have room. A labradoodle is 2 breeds in one, right? So the doodle obviously is the poodle portion. So it has the properties of a poodle because that's half of its breed. And then the other half is a Labrador, which... No, has a B in there. Labrador. I don't know. Anyway, oh no, there's no E. I don't know, that looks weird. But anyways, so a labradoodle has the properties of a Labrador retriever and has the properties of a poodle because it's both. And then it also has all the properties of a dog in general, right? It's got a wet nose, hopefully, if it's healthy. It's got 4 feet, also hopefully. So squares have all the properties of a parallelogram because it's a parallelogram. It has all the properties of both a rectangle and a rhombus. We're just going to do a rhombus today and then do a rectangle and square tomorrow. So, starting with this on page 3, classify the special quadrilateral and then explain your reasoning. I don't know why, but students get this wrong on their test. You have 4 options. It's either a parallelogram, rectangle, rhombus, square. So, what do we notice about this picture? All the sides are congruent, so now we've narrowed down, if we want to be as specific as possible. It is either a rhombus or a square. So which one does it have to be? A rhombus, so we're going to say a rhombus. So we knew it was a rhombus because all the sides are congruent. But how did we know it wasn't a square? Because it doesn't have a right angle. So we could say... but the angles aren't 90. Something. You just want to show how you eliminated a square, essentially. The reason I say people get this wrong, it's not because of their reasoning. They just don't guess the right shape. And I'm not. Just so we're going to practice. You have on your quiz next Friday, you'll have like a section where you tell me what the shape is. So the options are parallelogram, rectangle, rhombus, square, and a trapezoid, which we'll talk about. All right, and then we're going to talk about the properties of a rhombus. So a rhombus is a type of parallelogram. So the first property is that it has all the parallelogram properties. So go ahead and fill it in as number 1. Has all the properties of a parallelogram. All the properties of a parallelogram. So that means right away it has 4 properties that apply. The opposite sides are congruent and parallel. The opposite angles are congruent, and all that. So it's got 4 properties already. The second property that I list here is a part of the definition. What is the definition of a rhombus? What does it have that makes it a rhombus? 4 congruent sides. It has all congruent sides. You could shorten it to all congruent sides. The next 2 are special to a rhombus, but because a square is a type of rhombus, eventually you're going to learn that a square has these properties also. The diagonals are perpendicular. So the diagonals are perpendicular. Yes, ma'am. To the thingy. The diagonals are perpendicular. So that looks like this. So perpendicular means that they intersect and form 90 degrees, correct? Does that have anything to do with the length? No. The length is still, you know, that they're bisected, which means this length is the same as this one. But when BD intersects AC, they form a right angle, which means how many right angles are there at this intersection? There's 4. There just won't be drawn 4. You just have to know it. So the diagonals are bisected. The diagonals are perpendicular. And then they also bisect the opposite angles. The diagonals bisect opposite angles. Diagonals bisect opposite angles. So I'll give you the easy example. So if A were 80 degrees, what would angle C be? 80 degrees. What would angle B be? 100, which means angle D would be 100. So that property still applies where the angles across are congruent, the angles next to each other are supplementary, but the angles are cut in half by the diagonals. So that means angle A was cut into 2 pieces. What is each piece going to measure? Like if these numbers were A, B, and C, and D, what would the 2 pieces of angle A be if it was bisected? 40 and 40. Which means angle C would be 40 and 40. Angle B would be cut in half into 50 and 50. And then last would be D, 50 and 50. The last thing I want to show you is when the diagonals intersect, they form 4 triangles, yes? How many degrees fit in a triangle? 180. So if these two were 40 and 50, which we made up the numbers, 40 and 50 make 90, what does this angle have to be? 90, which goes along with the diagonals are perpendicular. It's going to happen every time. So in a rhombus, and even a square, the center will be 90, 90, 90, 90, and then you'll have 4 triangles. So it's a way to remember how to find angle measures, because we're going to use it here. So we're going to use all these properties to find the measure of angles. You are going to list measure of angle 1, measure of angle 2, measure of angle 3, measure of angle 4. I now have 101 students because I just got 2 added. I'm not going to look in your picture to figure out what your answer is. I'm going to look at your list and go from there. So angle 1, angle 2, angle 3, angle 4. We can start with angle 1. Angle 1 is formed by the diagonals. In a rhombus, what do I know about the diagonals? Well, the opposite angles are bisected. That's, yes, the diagonals do that. What else do I know about their diagonals? They're perpendicular. So that means, what's the measure of angle 1? It is at 90 degrees. 90, I just drew it all the way around. You don't have to if you don't want to. All right, and then someone already said it. The diagonals cut the angles in half. So, what's the other half of angle C going to be? 61, which means what are 2 and 3 going to be? 61 and 61. Because they're alternate interior still with 2 and 3, or with 61s. All right, and then you can find angle 4 a couple ways. I think the easiest way is to know this is a triangle, and in specific it's a right triangle. So you have 61 and 90. So how many degrees do we already have? We have 61 and 90, which is 151. Subtract that from 180. So that means angle D is 29. That's option 1. Option 2, if A was 61 and 61, what is the full measure of angle A and angle C? What's 61 plus 61? 122. So then how would you find angle D? Subtract from 180, which would make 58. And then you know 58 was cut in half. So half of that is 29. So that's option 2 to figure it out. We will pause here.